Hey, so this is a quick demo of the Goop. So these are two different machines in two different cities. This is a Raspberry Pi and this is my personal laptop, and they are behind different network IPs. So let's just quickly confirm that. So they're in different cities, and then they're accessing the internet via different IPs and networks. Right. So this is accessing the internet via this IP, and this shouldn't be pingable from here. Right. So it's not pingable. So this is where the existing decentralized solutions fail because they require you to have a public and static IP, and which is reachable globally. So that's not usually the case for consumers because we are behind an ISP, and we have dynamic and not public IPs behind NATs and firewalls. So here's where the Goop enters. So just let's quickly clone that here. I already have the Goop cloned on my local machine. Let's just go here. Yeah, and we have to install these dependency libraries. So SQLite is already installed. Let's try installing the stem library, which is the Tor library. Okay, so stem is also already installed. So let's run the Goop. So to run it, we just have to execute the Python CLI client, and let's just run it here too. Yeah, so it's starting Tor on both the sides. Now it's asking us for which port we have to run the local interface on. We can run this on any interface. Since this looks to be free, let's run it here. Let's just run it on some different port here. But these are different machines, so it doesn't matter. We can also run it on the same port. So yeah, maybe let's just run it on the same port. So what this has done is it's created a new hidden service ID. So this is our private address. So this is what we use to refer to each other in the good protocols. So I'll just enter this uh, because this is the address I want to talk to from here. I'll enter the address of this here, and it's asking for names. Let's name this Bob. Let's name this Alice. And now what they're doing is they're creating a network behind on top of Tor. So they're connected. So let's just see how that's working. Right. So this is an inlay into the Tor network. So what it's for every connection, what it's doing it's bouncing our connection through three different peer run servers on Tor. So so this connection which it's still building is being bounced through two German servers, and then there's this server in the Netherlands. Here this is bouncing our connection through France, Finland, and then the US. So what this ensures is that we have zero downtime, right? So we are relying on 8,000 public run nodes to keep our service online. So these both of these are connected, and now we can say, hey Alice, what's up? So it's near instantaneous. So the problem with stuff that works decentralized is that it's not that real time because it has to go through it goes through a centralized server. So what we are demonstrating is that near instantaneous real time communication, which is peerless, which is peer to peer and serverless. So right, so we don't have to run any servers to run this. These are just two different machines, and they are running local clients. Yeah, and more people can connect to it also alongside. So that's it. Yeah, that was it. Thank you. And you can see that it's actually changing connection dynamically time to time and for each network, right? So what that happens is that a single server that we are bouncing a connection through that can read our messages. So everything is encrypted through it. So we don't have to trust any one of these servers to ensure that our data is encrypted, because this server already gets the data encrypted from this server. So even if it can decrypt it, it's still an encrypted string. So what the decryption is happening on our local host, and the final uh, and the final so Bob, the thing which Bob encrypts is only decrypted by Alice, not the people in between. So that's the goop. Happy chit chatting.